small arms weapons fire semi-automatically. Some fire automatically. And some can fire both ways. Weapons giving automatic fire will fire continuously as long as pressure is applied to the trigger or until the ammunition is exhausted. This permits spraying of a target with a continuous stream of fire. Weapons designed to give semi-automatic fire deliver only a single shot each time the trigger is squeezed. Thus, each round can be individually aimed. These various types of fire require different firing mechanisms from those used on manually operated weapons. Let's look at a typical firing mechanism for a manually operated weapon to see why it won't work with a bolt that moves back and forth automatically. It's a hammer-type firing mechanism. As the bolt is moved to the rear to cock the weapon, it pushes the hammer back. Squeezing the trigger releases the hammer to fire the round. The bolt is moved back by the force of the explosion and is immediately closed by the return spring. Right here is the difficulty. The bolt opens and closes before there is time to release the trigger. Actually, it's faster than the eye can follow. As a result of this rapid movement, the sear is still held down by the trigger when the bolt is closed. Since there's nothing to catch the hammer, it follows the bolt forward, but it doesn't have enough force to fire the next round, and firing stops. In other words, a firing mechanism is needed that will stay cocked even though the bolt goes back and forth at terrific speed. First, let's build a typical firing mechanism for semi-automatic fire. Such a mechanism must remain cocked with the trigger held to the rear. It should fire when the trigger is released and then squeezed again. This can be done in a number of different ways. Here on our model, we've added a new sear of the same type as the first one. It is mounted so it can pivot independently of the trigger. Now, we'll mount a spring under the new sear to hold it up where it can catch the hammer. That doesn't completely solve our problem because we still can't fire the mechanism. We must be able to depress the new sear by squeezing the trigger. What is needed is a connection between the two sears. We'll put a link on the original sear. It pivots freely on a pin, but to keep it from pivoting too far, we'll put a stop lug on the original sear. Now the link always returns to its original position. The link is long enough to reach to the new sear, and to make contact with it, we'll put on another small lug. Now watch what happens. The hammer is held cocked by the new sear. When the trigger is squeezed, the link moves the new sear down, releasing the hammer. A fraction of a second later, the link slips off of the lug, and the new sear pops up to catch the hammer again. Let's see it again. The sears come down together, releasing the hammer. The new sear snaps up and catches the hammer, even though the trigger is still held back. To fire the next round, we must release the trigger. The link hits the lug on the new sear and pivots. After it passes the lug, it drops back into its original position, and the firing mechanism is ready to fire the next round. We now have a semi-automatic firing mechanism. Each time we fire, the bolt moves back and forth before the trigger can be released. But the new sear is up waiting to catch the hammer. Then we can fire the next round by releasing the trigger and squeezing it again. Semi-automatic fire. One shot each time the trigger is squeezed. To get automatic fire, we must arrange the firing mechanism so the weapon will fire continuously as long as pressure is applied to the trigger. We've seen how in semi-automatic fire, the hammer is caught by the new sear and held until the trigger is released and then squeezed again. But in automatic fire, the trigger will be held back. So we need a means of firing each time the bolt closes, even with the trigger back. That means on this mechanism, we must disconnect the new sear from the hammer each time the bolt closes. A part such as this disconnector will do the job for us. We've mounted it so that it can move up and down. As it moves down, it depresses the sear and releases the hammer. To move the disconnector each time the bolt closes, we'll put a lug on the bottom of the bolt. Now, as the bolt closes, the lug cams the disconnector, pushes the new sear down, and the hammer is released to fire the round. The bolt moves back and the lug clears the disconnector. The disconnector moves up and the new sear is in position to catch the hammer, even with the original sear held down by the trigger. The cycle starts over again, and the weapon will continue to fire as long as pressure is applied to the trigger. When the trigger is released, the original sear rises. Now, when the bolt disconnects the new sear, the original sear is up in position to catch the hammer and stop the firing. The hammer is held back, cocked, and automatic fire can be resumed merely by squeezing the trigger again. Now let's look at weapons which have both automatic fire and semi-automatic fire. These weapons have a lever to select the type of fire desired. These firing mechanisms are not much different from the ones we have just seen. All that's done is to arrange the disconnector so it can be shifted in or out of engagement with the new sear. With the disconnector out of engagement, the firing mechanism will give semi-automatic fire. One shot each time the trigger is squeezed. With the disconnector engaged, we'll have automatic fire just as we had before. That covers the basic principles for both semi-automatic and automatic fire. You'll find many different types of firing mechanisms on small arms weapons, but all of them have to perform the same operations we've pointed out to take full advantage of the speed and convenience of modern weapons.